In a world where waste management is a growing concern, our project Automated Waste Segregation and Smart Bins for Sustainable Future emerges as a solution to a issue faced by janitors and society at large. Traditional waste sorting methods often pose challenges for janitors who struggle with the meticulous and time-consuming task of segregating waste efficiently. Recognizing this challenge, we have developed a model that leverages image classification techniques to automate the segregation process. Beyond alleviating the burden on janitors, our innovation holds the promise of fostering a cleaner environment by ensuring accurate sorting of recyclable materials. By simplifying waste segregation, our project not only aids in the daily task of janitors but also contributes significantly to the broader societal goal of keeping our environment unpolluted and sustainable.
Developed image classification model using TensorFlow in Python, and in hardware prototype webcam in laptop took picture of the waste and saves it in Google Colab. If it's biodegradable, it sets value as 1, and for non-biodegradable, it sets value as 0 and sends this binary output to the Arduino IDE for titles. As waste enters the bin, the pretend image classification model detects the type of waste, and dustbin contains two compartments. If the detected image was biodegradable, it sets moisture level as 0 and tilts to left side, and if the detected image was non-biodegradable, it sets moisture level as 1 and tilts to right side. Servo motor is initially fixed with an angle of 90 degree. If it was biodegradable waste, the servo motor changes its angle to 0 degree and again come back to original position, and if it was non-biodegradable, servo motor changes its angle to 180 degree and comes back to original position.
A software journey using Google Colab, diving into the process by importing essential modules like OS, Keras, NumPy, Pandas, and Matplotlib along with their respective components. The next step involved mounting a Google Drive to access the datasets, that is, training, validation, and testing sets already stored there. The primary focus was training our model to distinguish between biodegradable and non biodegradable waste, utilizing folders of images for both along with a labeling CSV file marking 1 for bio and 0 for non bio waste. Validation came into play with a separate set of images and CSV files to confirm the effectiveness of our model's training. Moving to the test set, which lacked labels, it served as a means to verify the accuracy of our model's predictions. Multiple training iterations were conducted and accuracy was assessed through graphs generated by Matplotlib. Upon achieving a the desired accuracy threshold, we saved the model as a .keras file on our Google Drive. When it came time to deploy the model, we loaded it into a notebook, making necessary adjustments to enable webcam functionality for capturing waste object images. These images were then fed into the model, which classified them as either biodegradable or non biodegradable, providing a binary output. This binary output was then transmitted to the Arduino code, working in conjunction with an ultrasonic sensor to sort detected waste into the appropriate compartments based on the model's classification. Now we run our model, which opens the webcam feature of our laptop. Then, in front of the webcam, we place a plastic bottle, which is a non biodegradable object, and capture its image. Our model correctly classifies it as a non biodegradable object. We again run our model, which again opens up the webcam feature of our laptop, but this time we show a paper in front of the webcam, which is a biodegradable object, and our model correctly classifies it as a biodegradable object.
Now in our hardware setup, most connections are channeled through the digital pins on the Arduino board with the exception of the voltage connection which is directed to an analog pin. The moisture sensors link to pin number 3 while the ultrasonic sensors trigger and echo values are situated at pin number 9 and 8 respectively. The servo motor responsible for bin tilting is wired to pin number 12 and is powered by a regulator 9-volt battery for stability. To create a unified electrical system, we utilize a breadboard where all the sensors and the motor connected to ground and voltage points, ensuring an organized setup in our prototype. The servo motor receives electrical signals from the Arduino through pin number 12, allowing it to rotate precisely to angles like 0 or 180 degree. This movement controls the bin compartment's tilting, aiding efficient waste segregation. Meanwhile, the ultrasonic sensor operates by emitting waves through pin number 9 and measuring their echo at pin number 8. By calculating the echo's return time, it gauges the distance between the sensor and waste, crucial for activating the bin's tilting mechanism based on the waste type detected. Lastly, the moisture sensor linked to pin number 3 gauges the waste moisture level. If waste is identified as biodegradable, it sets the moisture level to 0, indicating its organic nature. Conversely, for non-biodegradable waste, the moisture level set to 1, aiding the system in accurate waste segregation based on composition.
Through automated waste segregation and smart bins for a sustainable future, our project pioneers a crucial step towards efficient waste management. By integrating technology into bin design and waste classification, we have simplified the process while contributing to a cleaner environment. This initiative doesn't just streamline waste sorting but represent a significant stride towards a more sustainable tomorrow where the harmony between technology and environmental consciousness creates a better world for all.